In today's video, we're going to be talking about projectile motion. Now, basically, a projectile motion is simply the motion of a body in which, when the body is being projected into space, the only force that acts on it is gravity. This simply means that air resistance and any other external force that acts on it is being neglected. Okay, now there are cases of projectile motion in which I'm going to divide into three categories in this video. Okay, now the first one is simply the easiest, and it will help you understand the other cases. So I'm going to start with case one for a projectile motion. Now for case one, a body is projected from the platform, okay, which could be on a table or on the ground. Okay, it is projected at an angle to the horizontal and to the vertical. Okay, it travels through space and then it returns back to that same platform. So I'm going to draw a diagram here to illustrate what I'm trying to say. Okay, now here is the body at its origin, and then it is projected like this. It travels through space and then it returns back to the platform. Now I just said at an angle to the horizontal or to the vertical. In this case, let's make use of angles in the horizontal. Okay, now remember, to project the body, we need to do that with a speed. Okay, we need to do that with a speed or a velocity. Now, if we are projecting this body, we are going to do that with a velocity, and that velocity is what I'm going to call u. Okay, so let's start with the velocity. We are going to call the velocity u or v, of which in this case it is the initial velocity, so it's best to describe it using what now? U. Now, talking about the velocity for this whole diagram, the velocity is divided into two components. We are having the horizontal component, okay? I'll call here x and I'll call here y. We're having the horizontal component after it is being resolved, and then we're having the vertical component after it is being resolved as well. Okay, now for the horizontal component, what's going to be the initial velocity? Initial velocity for horizontal component, u represents initial velocity, x tells us is the horizontal component, and that's going to give us, if the velocity we're projecting which is u, that's going to give us u cosine of theta. Of course, we are resolving it to the horizontal, so that's what I'm going to get. Okay, and then for uy, we're going to get u sine of theta, resolving to the vertical components. Now, a projectile is basically a combination of a horizontal motion, okay, and a vertical motion. So they are being combined. When they are being combined, they now form an object or a projectile, which is actually the body traveling that moves in a curved path like this. Okay, the path is called a trajectory. Now, for that reason, it means you can apply equations for a horizontal motion as well as equations for a vertical motion. Okay, now what are the equations of a horizontal motion and what are that of a vertical motion? I'm not going to be writing them here, but I'm going to be making use of them to solve these questions. Okay, now firstly, let's talk about the velocity. Okay, now the velocity for the initial resolved components of x, we have u cosine theta, and for y we have u sine of theta. Okay, now you notice for this diagram, the highest point that the body will travel is from the center down to the platform. Okay, when we chase this point to this point, it's not as high as this. We chase from here to here, not as high. Okay, so the highest point to notice is what now at this center, that is the apex. Okay, now the velocity, let's talk about x first. The velocity initially is u cosine theta at this point. Now take note that ux is going to be constant all throughout this part. Why? Because we are seeing a projectile is a combination of a vertical and a horizontal component, and for a body that is projected horizontally on the ground, okay, we observe that the velocity is going to what now? Act constantly all throughout the what now? The path. Okay, so ux is going to be constant all throughout until it gets to this point. So for here, ux is the same, for this point, ux is the same, and for this point, ux is the same. That is, it moves with a uniform or a constant velocity. Now, if it moves with a uniform or a constant velocity, it simply tells us that g does not act on it, okay, because it's moving horizontally, okay, and then acceleration is equal to what now? 0, okay, so that's for x. So from here, ux is constant, ux is constant, ux is constant. Now, if ux is constant, what does that tell us? It tells us that vx is equal to ux, okay, because v simply means apart from this point, what other velocity are we considering for the horizontal component? Okay, now vx remains what now? constant as well, and Vx is equal to what now? Ux. So Vx and Ux, they are what now? The same thing. Okay, now how about Ui? Ui has to do with the vertical components. Okay, now Ui is equal to U sine of theta. If I project it through this part, okay, initially it's having Ui. Now the velocity will start decreasing because acceleration is acting on it. What type of acceleration? Gravitational acceleration. Gravity is pulling on that projectile. So as it's moving from this point, before it gets to this point, its velocity starts decreasing. So Ui is not constant, okay, it varies. Now when it decreases, it gets to this point, we're not having V, right? Now Vy, which is the vertical component's final velocity, will be equal to 0 at this point, which is the highest point, okay? While Ux remains the same, okay? Now as it is coming down again, what happens? Ui starts increasing, okay? Ui starts increasing until it gets to this what now? This point again, okay? That's what's going to happen. Now, how about the total resolved velocity? What's going to be the total resolved velocity? The velocity V, which is the total component velocity, is always the square root of Ui squared plus Ux squared, okay? Or we could say it's equal to the square root of Vy squared plus Vx squared, okay? Of which we know at this point it's only having the the Vx rather, okay? Because with Vy in this place is 0, we're going to have 0 here, and we're left with what now? Just Vx. So for this place, you can choose not to use this formula. So if you're asked to find the velocity at a particular point, this is the formula to use. We find Ui, we find Ux, or we find Vy and find Vx. Put it into the formula and we'll get our answer, okay? That is how it is being done. Now, the next thing we're going to talk about is the time, okay? We're going to talk about the time. Now, the time we're going to discuss first is the time it will take for the projectile to travel from this point of displacement, okay, this origin, down to the highest point, this apex, okay? From this point down to this point. That's the next thing we're going to talk about, which is the time. So from here to here, we need the time it will take the body to travel. Now, mind you, to travel from here to here, we are going to call it a time t, okay? And it is the same time it's used for the body to travel from here back to the point of platform. You can see there are two equal halves, okay? They are symmetric. So I'm going to have another time here, of which the total time becomes what now? 2t, okay? Now, for the time here, okay, you don't have to count the formula. How we're going to do this? Just watch. Now, in this case, we are trying to determine the time taken for the body to move from the bottom to the top. Okay, not from here to here. Okay, this one is a horizontal part. We want the time to take to move from the bottom to the what? To the top. That's what we want. Okay, and we could make use of any of these equations of motion. But since we are dealing with the vertical, we have to make use of an equation that has to deal with what now? The vertical motion. Okay, now the equations, you know, the equations are first of all Vy equals Uy plus or minus gt, okay? That's the first equation. And then we have h is equal to uyt plus or minus 1 over 2 gt squared, okay? And then we have vy squared equals uy squared plus or minus 2gh. Now these three equations, they are having y attached to them simply because the y is telling us that it is for a vertical motion, okay? That's the only difference. So if I'm to convert this into a horizontal motion, I should be having x on these places first, and then displacement, I'll be replacing h with x or s, okay? And then g becomes what now? A. Now we're trying to determine the time taken for the body to move from this point down to the apex, that is the highest point, okay? Let's make use of this first equation. So for the first equation, we're having vy equals uy plus or minus gt, okay? Now the body is going upward. When the body is going against acceleration, you should make use of the negative sign. So instead of having a plus or minus negative, I'm going to be having just a minus sign. So you're having uy minus gt, okay? Now, how are we going to get an equation that describes this time, this multi here we're looking for? Now, at the maximum height, so we're looking for time taken to move from this point down to this point. But remember, at the maximum height is what is the time we require, right? Now, at this maximum height, Vy is equal to 0. So first things first, Vy equals 0, okay? Now, how about Uy? We've done Uy before. Uy is always U sine of theta, so we can substitute. Then we're going to have U sine of theta minus Gt t. Okay, so now when I make t subject formula, I'll get gt equals u sine of theta, and then t is equal to u sine of theta over g. Okay, now this is the equation for calculating time taking to reach a maximum height. Okay, so I'm going to call this time taken to reach maximum heights. Okay, time taken to reach maximum height of a projectile. Now I just said that the time taken for the body to travel from here down to the maximum height, which is the highest point, it's also the same time to take to travel from here down to this point, since both sides of the graph are what now symmetric. Okay, so now what if we're asked to calculate the total time? If we're asked to calculate the total time, we're just simply going to add these two times. Okay, this one is u sine theta over g, which we've put there. This one is as well u sine theta over g. Okay, so u sine theta over g plus u sine theta over g gives you 2u sine theta over g. Okay, now that time I'm going to write as big T. Okay, so you don't get confused with this small t, and that's going to be equal to t plus t, which equals 2t. Now substituting in t for u sine theta over g, we're going to get t equals 2u sine theta over g. Now this big T has a name, okay, and this name is what we call the time of flight of a projectile. The time of flight is simply the time taken for a body to move from the point of displacement, travel through space, and then return back to its point of displacement. So big T is 2u sine theta over g, and this is called the time of flight of a projectile. The time of flight. Okay, this is what we call the time of flight. Now, having done that, we've talked about the velocity, how it varies across a diagram like this. Now, we just talked about the time, that the time taken to reach maximum height, and then time taken to travel through space, return back to the platform of projection. We just talked about 2 times. Okay, now the next thing we're going to be talking about is the maximum height. Okay, how do we determine the maximum height of a projectile? How is it being done? How do we determine the maximum height? Now, I'm going to call here h max. Now, of course, notice there are different heights in this diagram. From here to here, there is a height. From here to here, there is a height. From here to here as well, there is a height. All through the diagram. But we want to determine the points where the body will be at its highest point, that is its peak, above the ground. So from here to here, we should be having the maximum height. Okay, this diagram is not drawn to scale, so you might score that here is the highest spot. For simplicity's sake, I'm going to take this middle one as the maximum height. Okay, now how are we going to determine the maximum height? Now it will be easy as well. This is because I just said if we're talking about a quantity that has to do with the vertical, we should be considering vertical motions, and if we're talking about a quantity that has to do with the horizontal, we should be talking about horizontal motions. Okay, now in this case, maximum height has to do with the vertical, so we're talking about vertical motions. In this case, we're asked to determine the maximum height. Now, how are we going to determine the maximum height? We're going to make use of one of these equations. Look for which one will help us get our answer, which one works best. Now, seeing these equations, these two equations, I can choose to make use of these two. Okay, yeah, I can choose to make use of these two equations. I either choose to make use of h and substituting for the time, okay, and every other parameter that follows. So I can choose to make use of v. V squared equals u squared plus 2gh. I can just make use of this one, okay, depending on the one I want. Okay, it doesn't really change anything. Now let's make use of this second one, which is vy squared equals gy squared plus or minus 2gh. Okay, so if I'm going to make use of this one, I'm going to have vy squared equals uy squared plus or minus 2gh. Okay, now what are the conditions for maximum height? Conditions for maximum height. This is maximum height. What are the conditions? In this case, vy is equal to 0. Yeah, now vy is equal to 0, so I'm going to have 0 squared equals, what about uy? Now uy at the maximum height. Okay, uy at the maximum height. Now remember, uy is u sine theta. Okay, so uy is u sine of theta all squared. Yeah, uy is u sine of theta all squared. Okay, and we're having plus or minus. Now, how are we going to know if we're making use of a plus or minus? Now, the body is traveling from this part to this part. So I'm considering this place first. Okay, moving from here to here, and it is against gravity, so I'm going to make use of the minus sign. So instead of having a plus or minus, we're going to have minus 2GH. Okay, that seems pretty easy. So from here we can simplify. We're done with physics here. We just want to go into the maths. Now 0 squared gives you 0, so we're going to have 0 equals, expanding these brackets, we're going to have u squared sine squared theta minus 2GH, making h a subject. That is, we're going to make 2GH subjects first. Okay, so we're going to have 2GH equals u squared sine squared of theta, and then h is equal to u squared sine squared of theta divided by 2g. Okay, now this equation gives us the maximum height for a projectile. So I'm going to call it the maximum height for a projectile. Okay, maximum height for a projectile. Okay, assuming this case. Now I'm just talking about the velocity, the time, and not just the time of flight as well, and then the maximum height. What's left? Now we might also be asked to determine the distance from this point to this point. Okay, that is the maximum distance to travel horizontally, and that is what we call the range. Okay, how do we determine the range? Now the velocity here is constant. We do not need to start debating between Vx and Vy. Sorry, Vx and Ux because they are the same thing. Okay, Ux and Vy, they are the same thing. Now, how do you determine distance? Now, take your mind off range and let's talk about distance first. We're dealing with the horizontal, so these equations will not apply. We're only going to mix of equations that apply to horizontal motion. Okay, now we're dealing with the horizontal. First of all, we do know that velocity, okay, in this case I'm going to write x. So you have Vx, this x is a subscript, okay, telling me that it's for the horizontal. Vx is equal to displacement over time. Yeah, but take note, this time is the time it takes to move from here to here. What I should be using is the time it takes to move from here to here, because I'm covering not this distance but the whole distance. Okay, that's what I should be doing. So instead of small t, I should be having big T. So please do not make that mistake while solving. Okay, now from here we're looking for x, so x is simply equal to Vx times t. Yeah, okay, now x is now equal to Vx, which we've solved several times. Vx is u cosine of theta, which is same as ux. Okay, so I'm going to have u cosine of theta times, now what's big T? Big T is the time of flight, which we've solved already. That's 2u sine theta over g. So I'm going to have 2u sine of theta over g. Okay, so from here x is simply equal to, now we can simplify further. 2u times u, that gives you 2u squared. Okay, and cos theta sine theta gives you cos theta sine of theta over g. Okay, that's what we're going to get. But I think we can simplify this further using some trigonometrical functions. Okay, so this should be quite easy. Okay, now first things first, I want to put this u squared first. Okay, so that I can break these two, because if I should bring this to here, it reminds me of a very common trigonometrical functions. Okay, so I'm going to write this as x is equal to u squared 2 cos theta sine of theta over g. Now if you recall, this 2 cos theta sine theta over g, 2 cos theta sine theta is a very familiar equation for mathematics. Okay, a very familiar equation in trigonometry. So 2 cosine theta sine theta, what does it remind you of? I think that should remind you of sine 2 theta. So I'm going to come here and write, recall 2 cosine theta sine of theta equals sine 2 theta. That's a double angle function. Okay, so if I substitute, I'm going to get x equals u squared. Okay, so for 2u cosine theta sine theta, I'm going to write sine 2 theta. So I have sine 2 theta over g. Okay, now since we're looking for range, I'm going to call this x range. So I'll represent this as r equals u squared sine 2 theta over g. Okay, that should be over g. Okay, so this is basically the formula for calculating range. Now some of you might still be confused as how I got sine 2 theta. Okay, I'm going to show you, but it's something that should be done in mathematics, so I'm just going to brief you guys about how it's being done here. Now there's what we call the double angle function. Okay, now if I have sine of theta plus phi, okay, sine of theta plus phi, that's equal to sine theta cos phi plus cos theta sin phi. Okay, that's sin theta cos phi plus cos theta sin phi. So if I'm having a negative, I'm still going to be having a negative sign there. So I'm having a plus or minus. Okay, if there's plus, it should be plus. If there's minus, it should be minus. Now, what if theta now equals phi? So we'll be having two thetas. That will be equal to sin theta plus theta. Okay, equals sin theta cos theta plus cos theta sin theta. Okay, now we're having sin theta cos theta, we're having cos theta sin theta. I can put any one first because multiplication is commutative. So I'll write this one as sin theta cos theta plus, I'm going to interchange this one, which is same thing as sin theta cos theta. Okay, now sin theta cos theta plus sin theta cos theta, that's like adding two similar items together. So I'm going to get 2 sine of theta cos theta. Okay, and then we'll as well rearrange it again, bringing the cosine first. I'm going to get 2 cos theta sin theta. It doesn't matter whether you write cosine first or sine first, you'll still be marked if you ask a question like this in an examination hall. Okay, this is what we just obtained. Now, and remember, this is equal to on this side. Okay, sine theta plus theta gives you 2 theta. Yeah, so I'm going to have sine 2 theta is 2 cosine theta sin theta, of which we just obtained here. 2 cosine theta sin theta, which we're having here, is sine 2 theta, so we can replace it like this. Okay, so anyhow you want to do it, anyone that makes you understand everything we've just done here easily, then I think that's what you should be doing. Okay, so it's as easy as that. This case 1. On our next video, I'm going to talk about case 2 and case 3 for a projectile motion. So if you did understand how a projectile motion works, I would like you to share the video to your friends, your colleagues. Okay, help them learn from these videos as well. And more videos will be posted on this YouTube channel. The YouTube channel is Dr. Flash. So you can as well do it to subscribe to the channel so that you get more videos when they are being uploaded. And also do not forget to click on the notification bell so that when a new video is being uploaded, you'll be one of the first 2 persons that will get notified about this video on projectile motion. So like I said, the next videos that I'll be uploading still on projectile motion. We're going to be talking about case 2 and case 3. So guys, see you in the next video. Thank you.